Dear viewers, welcome to our online channel at Steve Getau 3660. I am your online teacher, Mr. Steve Getau. Today, I would like us to look at a topic in Form 2, that is mastering on writing chemical formula. This is a topic that is taught in Form 2 chemistry, but you'll find it very suitable for our Form 3s and Form 4s who would like to revise on how to write the chemical formula. Maybe before we take off in the lesson, I would like to remind you about our organization in this channel, that we have organized it in terms of content in two subjects, that's mathematics and chemistry. And on the channel, we have these videos available independently on the platform of the YouTube channel, but we have also organized it in terms of playlists, whereby we have a playlist for Form 1 chemistry and Form 1 maths, Form 2 chemistry and Form 2 maths. That way all the way up to Form 4. In each form there are two folders with the subject, maybe chemistry or mathematics. So viewers, this organization will enable you to look at the content that you are interested in, and you will find it exactly in your particular form. More to it, if you would like to view all of the videos, they are available in the combined playlist. If you'd like to view only the chemistry ones, they are also available in the chemistry video playlist. All mathematics are on the same way. Otherwise, viewers, welcome to this lesson for today, and it's my hope that we are getting to benefit so much as we revise, as we go through the new content. And my wish is that you will share the link to this video, you will comment on the space below the video, and you'll also subscribe so that every time I upload a new video, you'll be the first one to be notified. Straight away we go to the classroom, and in this we look at how to write chemical formula. Now, when we are discussing on how to do the writing of the chemical formula, it is very important to recognize the chief item. The chief item here is to master two things. One, the valency of various elements, be they metals or non-metals. So generally on the screen, I've provided you with a table that shows the valency of various metals which are commonly used. The moment we master these ones as the basic foundation to this, you'll find that others in the periodic table, you'll come to master them very, very easily. Metals are put in three valencies. Remember, learners and viewers, what is a valency of an element? The valency of an element is actually denoted or defined as the number of electrons an atom of that element requires to lose or gain so as to form a stable configuration. So in this grouping, we have sodium being in the group that has valence 1, together with potassium. Amongst the elements that have valency 2, that is metals with valency 2, include calcium, barium, magnesium, zinc, iron, lead, and copper. Metals with valency 3 include aluminium and iron. It is important to note that iron has 2 valencies, so we shall be very particular when we are referring to iron 2 or iron 3. The moment you get to hear of iron 2, it means the iron atom has valency 2. And when we get iron 3, the same way. The iron atom at that point has valency 3. Let us look at the valencies of nonmetals. This is important because you realize that metals and nonmetals usually react in forming the ionic compounds. And so we need to know in what ratio the two react. Straight away we look at the nonmetals that fall under valence 1. And these ones include nitrogen, chlorine, fluorine, and hydrogen. Those that are, or that the elements that have valency 2 include nitrogen, oxygen, and sulfur. The nonmetals whose valency is 3 include nitrogen and phosphorus, amongst others. These, as we had said, hinted earlier, actually form the basics that will enable us write the chemical formula that we need. You will notice that this subtopic is a precursor. It comes first as we get to the second topic on balancing chemical equations. So a learner will require the knowledge on how chemical formula is written, so that we move to the next level during the third video, whereby we shall look at balancing chemical equations, where we shall have mastered on how to write the chemical formula of individual compounds. Very important, learners, if you check on the screen, I want to use my moving cursor to highlight that nitrogen 1, or is grouped in valence 1. The same case, we have nitrogen in the group that has valency 2. We have nitrogen also being in the group that has valency 3. Why is this so? So you realize that depending on the compound, we have nitrogen reacting with the oxygen to form nitrogen 1 oxide. Nitrogen also reacts with oxygen to form a compound called nitrogen 2 oxide. Nitrogen 2 oxide. We also find that nitrogen reacts or in its elemental form has the arrangement 2, 5, and that gives it a valency of 3 in its elemental form. An atom of nitrogen has a valency of 3. That means it requires 3 more electrons to be added to it so that it becomes stable. So that is the explanation why you find nitrogen featuring in the 3 groups with the 3 different valencies. Let's move on to a third category of the valencies of radicals. Learners, we need to understand what are radicals. Radicals are groups of atoms that react together as a unit, and they bear, or they have, a net charge. What do I mean, or what do we mean? If you look at the first example, maybe I take one at random, the ammonium ion, NH4 positive. You find that nitrogen combines with the 4 hydrogen atoms, and the compound formed, or that grouping of atoms, have a charge of positive 1. In the topic that will be coming up next, that is structure and bonding, we shall realize how ammonia molecule combines with a hydrogen proton to make an ammonium ion. So the ammonium ion, amidst the fact that it is composed of 2 different elements, they are able to react as one, and they bear a positive charge, just like the elements sodium and potassium that have a valency of 1. So that's what we are saying, or negative. It may also vary in terms of the size. It may be +1 or -1, -2, or so on. Now, straight away, let's look at the table. We have radicals that have a valency of 1, and this one includes the ammonium ion, the hydroxide ion, the nitrate ion, the hydrogen carbonate ion, and the hydrogen sulfate ion. Amongst the radicals that have valency 2 include the carbonate, the sulfate, and the sulfite. Now, viewers, it is very important you master straight away on the formula of the radicals before we combine them with other elements. You find that where the radical is made up of two different elements. Take, for example, the hydroxide ion, the OH. Oxygen is written in capital form. The hydrogen is also in capital form. And that cuts across all the other radicals. Straight away, let's move on to the valency 3. We have the phosphate ion, PO4 negative. You find that the phosphorus, capital P, the oxygen, capital O. And that is how we are able to show the valencies of the radicals. Another very important point is where the radical is made up of 2 or 3 different elements. Take, for example, the hydrogen carbonate, HCO3 negative. We encompass these 3 atoms, 3 different atoms, with brackets, so that if they are required to react when there are 3 of them, then we would be able to put a 3 after or at the end of the brackets. And normally we put it as a not as a subscript, but as an underscore in that formula, and we shall be able to see that one. I would like us to do an assignment together. In this assignment, I'm going to provide a table of, or using the table of valencies for metals and radicals, we write down the chemical formula of the compounds which are formed between the particular metal given and the radical. On the screen, I've provided you with a table. In this table, let me take you through what it contains so that you have a very good understanding of what we are doing. We have the metals. The metals include potassium, sodium, potassium, magnesium, calcium, aluminium, zinc, lead, copper, and iron, and I've specified there iron too. In the next column, I would like you to put the valency of each one of these. So we remember we had another table earlier on where the valencies were shown. You can make reference to it. Sorry. Then after that, you find that these metals will either combine with some non-metals like chlorine. So we shall be able to form sodium chloride. So the question is, what is the formula of sodium chloride? We write it in the space provided. I want to show that with the moving cursor. We write it in the space provided here. What is the formula for sodium nitrate? Here I have given an example of sodium carbonate. You realize that the valency of sodium is 1, so we close it and we provide 1 carbonate. The valency of a carbonate radical is 2, and upon crossing down, we form two sodium atoms. So that is the reason why the formula of sodium carbonate is Na2CO3. The carbonate has a valency of 2, the sodium has a valency of 1. So we shall fill in all the remaining spaces with the respective chemical formulas of the particular compounds given. In the last column, or second last, we have sodium sulfate. we have sodium hydroxide. And that one should be done for each and every of those compounds. So we shall have sodium chloride, potassium chloride. We have been given potassium nitrate. So we fill in for potassium chloride. We do not have any other item filled for us, so it is upon us in the assignment to fill in. So viewers, I would like you to pause on the video, get your notebook, put the columns and write down each and every of those chemical formulas. Being guided by the earlier table, you can scroll back and check on the valency of each of those elements or radicals. So fill in, and I would like you to very carefully note on the item that we talked about, putting the brackets. On the moving cursor, I want you to note calcium hydroxide. Calcium hydroxide. You find that calcium has a valency of 2. That's why we have these 2 here. The hydroxide has a valency of 1. That's why we have a 1 here. But we normally don't show it. The 1. So because the oxygen and hydrogen are different elements and they have combined as 1, we say that OH react as 2 of them. 2 of the OH. The same case with aluminium chloride. The aluminium has a valency of 3. I think we shall remove these brackets. They're not particularly necessary because the chlorine is taken to be one element. It's not that Cl are 2 different elements. So it should be AlCl3. The brackets encompassing on the chlorine are not very necessary. So I want to say that again. The formula for aluminium chloride therefore should be AlCl3. Very important to note here that the L in aluminium should be a small letter L. That is a stroke without showing the elongation. When you put the curve at 90 degrees on L, that becomes a capital letter L. The same case with the L in chlorine. It should be a stroke, and that way we are able to show chlorine in terms of capital C and small letter L. So viewers, take 10 minutes to fill in the table so that in the next slide I'll show the solutions. Take some time. You can pause on the video. I would like our lesson to be as much interactive as possible. Interact with the technology, interact with the assignment, and so that next time, in the next 10 or so minutes, we shall interact with the expected solutions. Take your time, work on the table, and so that I may be able to give you the solutions in the next 10 or so minutes. Solutions to what we were having in the top part of the first part of the table. We had sodium, valence 1, potassium valence 1, magnesium valence 2, calcium valence 2, aluminium valence 3, zinc valence 2, lead valence 2, copper 2, and iron valence 2. For the formula of the chlorides, we have NaCl for sodium chloride. The same case with potassium chloride. So the best thing is get some lead pen. We mark as we move on. You realize, as we had said earlier, the symbol for the first letter of the element forming that compound should be capital. So magnesium chloride, we have capital M and then small letter G. Capital C, small letter L. So for magnesium chloride. We have calcium chloride, aluminium chloride, zinc chloride, lead chloride, copper chloride, iron chloride. In the nitrate section, we have sodium nitrate, potassium nitrate, magnesium nitrate. In particular, I would like you to see the way we've shown the magnesium nitrate. We have a nitrate radical having valence 1 and the magnesium having valence 2. And that's why we enclose the nitrate with a 2. Calcium nitrate, aluminium nitrate, zinc nitrate, lead nitrate, copper nitrate, and iron nitrate. Amongst the carbonates, we have sodium carbonate, Na2CO3, potassium carbonate, K2CO3. And runners, I want to emphasize on between carbon and oxygen. These are two different, so they need to be shown in capital letters. Magnesium carbonate follows there. Calcium carbonate. Remember, the valence is a 2, magnesium is a 2, but normally we say divide by the common number, and that reduces to 1, 1. So magnesium 1, carbonate 1, and we normally don't show the ones. We have calcium carbonate, aluminium carbonate as AlCO3, and then we encompass that with a 3, or we close the with brackets the CO3. Why is it so? The aluminium has valence 3, and the carbonate has valence as a valence of 2. So that is a correction on our scheme there. On our solution set, we have Al2CO3 close with a bracket 3. Then we have zinc. I move back a little bit. We have zinc carbonate, lead carbonate, copper carbonate, and iron carbonate. Amongst the sulfates, we have sodium sulfate, Na2SO4. The reason is similar with what we have just said. The sulfate has a valency of 2, and the sodium has a valency of 1. So the sulfate is not necessarily encompassed or enclosed with the brackets because the SO4 radical is only 1. Potassium sulfate, magnesium sulfate. Under magnesium sulfate, we find that the valencies cancel out. We have magnesium with the valency 2, the sulfate with the valency 2. So they close out. The same case with calcium sulfate, aluminium sulfate. I think this now corrects it very well. We have the sulfate with the valency of 2, aluminium with the valency of 3. Aluminium, I think that should be zinc sulfate, ZnSO4. We each with the valency of 2, so they balance out. Lead sulfate, copper sulfate, iron sulfate. Amongst the hydroxides, we have sodium hydroxide. I would like you to specifically see the way we write that formula. N is capital, A small. O and H are capital. For potassium hydroxide, we have all capitals. Magnesium hydroxide, calcium hydroxide, aluminium hydroxide. We also have zinc hydroxide, lead hydroxide, copper hydroxide, and iron 2 hydroxide. In this case, where the valency is specified, for example, we can have another column for iron 3. So you'll find that the formula will change because now the valency of iron has moved to 3. Viewers, we look at a revision question which I would like us to read together and then kindly work it out and post it on the comments section, and I will be able to reply to your answer. An element X has electronic arrangement 283 and Y has the electronic arrangement 26. Write down the chemical formula of the compound formed when X and Y react. That gives you 1 mark. In question number 2, an element P has the electronic arrangement 2H2. Write down the formula of its sulfate, its chloride, its carbonate, and nitrate in the table below. So the most important thing is to identify the variance of P and then match that with the respective variances of the radicals given there, and you'll be able to fill in that table very well. Viewers, we come to the end of our online lesson at that point, and I would like you to redo this over and over again so that in our upcoming video, and that is on writing balanced chemical equations, you will be required now to have mastered the chemical formula of each compound, and what will now be running at that point is how to count the numbers of atoms on the reactant side and on the product side, and making sure that that number is equal, and that's basically on balancing. Viewers, subscribe to the video, my channel there at Steve Gitao 3660, share and comment, and I'll be able to make better and better videos every day. I want to thank you for listening and also making the participation that I've seen in the earlier videos in a very great way. Thank you, and wow, it's cheers for you. Have a great day. Thank you.